presentation. Okay. Thank you. Okay. Thank you for your attention. Okay, first of all, I explained the drafts I sent you before. I'm reading several papers. This paper is published in 1981, but when I was a graduate student, I read through these papers as for the teleconnection. And this is very big paper, but provides me very interesting information. And also I read through the papers Professor Williamson wrote in 1999, teleconnection between Pacific Sea surface temperature and Canadian prairie oil yield. And in this paper, Williamson conducted the correlation coefficient survey with the sea surface temperature with yield in a grid scale.
Want to put it here.
This one, yeah. You don't remember this?
Oh, yeah. Okay. I see here.
Yeah.
Is it?
Yeah, so Williamson compared with the gridded sea surface temperature data set with yield. So first of all, I thought I should conduct the correlation coefficients to the data sets that I'm now generating. So the first page is a summary of the papers I read through this last week's. And second page is processing data sets. So now original data sets is it's drawn in left, and original data set is something like this. This is the original data sets starting from 1979 in fall to 2006. So using these data sets, I generated I selected the areas by 10 by 10, it means 100 grids, and also the suggestion of the Professor Williams sensei, I calculated the number of cells with sea ice and the number of cells of open sea. So the below is a list of each data set. So the number 2 means the sea ice, and the number 255 means open sea. So calculating the number of cells with sea ice, and also I calculate the number of cells with open sea. So the second page is bottoms. The sea ice extent ratio in each grid is computed as ratio equal number of sea ice cell dividing number of sea ice cell by number of open sea cell plus number of sea ice cell. So this is the data sets I generated now. So this is the position from 11 to 1010. So the hundreds of cells is here. And the data sets, it takes time to generating the data sets. So at this stage of now, I starting from 1978, October the 23rd, to 1998, December, the end of December. So the number of data sets is almost 1,000. So the data set is still in progress, so I'm working on to generate the data sets until 2006, but it still takes time. So this time I will introduce the result about this stage of now.
So I still have a question. So these things. So this cell. This 2, what does that 2 mean?
2 means the cell with sea ice.
2 plus sea ice.
Sea ice.
There's 2 cells with sea ice?
No, not 2, but the original data set is something like this. It's the original data set.
2 represents sea ice. You have a 2 there.
Oh, 2 in your data point means the sea ice.
Yes.
And 255 is open sea.
the data mass.
Oh, okay.
So the original data sets are 721 by 721, and each cells has a value from 0 to 255.
Oh, okay.
Okay.
So what about the other values in between?
Like this. Other values.
There are no other values.
Other values is they have the explanation of the data set. This is the original data sets provided by the National CI Center in University of Colorado.
Right.
And each cell, there you can see the number here. So that this, if, for example, this portion is at 255, and this portion is number 2. That means CIs. So I selected these areas and divided into 10 by 10 cells.
Right.
And counted the number of CIs and also counted the number of open C in each point.
Right.
This is a data set.
And you said each grid includes 30 by 30 cells, but that's only near the center, right? 30 by 30 cells.
I divided into, okay, this is a selected area.
Right.
So I divided it in this area, divided it into 10 and by 10.
Right.
So 10 by each cells. Each cell includes 30 by 30 equal 900 cells here.
So what you're saying is that each of these, so you divide into 10 of those. And
Yes.
Each of those has 30 by 30?
Yes, that's true.
But I thought it was only 3 to 30 because the grids get smaller.
Yes. So
here you have 3 grids.
Yes, so your suggestion is divide ratio, calculate the ratio.
Yeah.
So I calculate the ratio equal number of dividing number of CI cell by number of open C cell plus number of CI cell. So that I calculate for
because the actual cells are bigger than the cube, so you have less than 30 by 30.
Yes. So using these data sets, this is the number of cells expressing open C from 1 to 10, and also this is the number of cells with open C from 1 to 10. And then this is a ratio of the in each cell in the ratio of the CIs exist. So making use of this data set, I conducted a correlation coefficient survey. Next page, last page, very small one. Sorry, very small one. Using the excluding the data set without data. This is a correlation coefficient data set. So that is the analysis is still in progress. So this is the first results of the correlation among each cell. So then,
so this is 100 by 100?
Yeah, 100 by 100. Yes. 10 by 10 ですから。Yes, 100 by 10.
100 by 100, right?
Yeah.
100.
Yes, 100. Yes. But the cells.
0.5.
The cells without with no data is excluded.
0.8, 0.7. You can find it.
Just 0.8.
So for example, the 0.11 and 0.12 and 0.13 with no data, no ratios. So they are excluded for that. But the 0.14, for example, they have the slight data sets here, so it is included. So the excluding the data sets with no data is excluded, and calculate the relationships. So I will still continue to generating the data sets as for the CIS extent. And then next stage, I want to compare with each grid cells with the data sets Dr. Alex provides me last summer, and Arctic flow events data sets. And also I want to compare with temperature and precipitation data sets in the British Columbia areas, and also agriculture production data sets, just like you did on these papers. So my work still in progress. So trying to figure out the relationships using MATLAB. I have just started using MATLAB.
So also like better than Excel. In Excel,
Are you doing all this by Excel or everything?
At this stage, I'm not trying to input the data, generating data sets to MATLAB.
Okay.
But it takes time.
Yeah.
But maybe I hope I will be able to use MATLAB.
Yeah. But it saves time in the future, because if you do that using MATLAB or R, so it would be like easier than Excel.
She provides me the manuals of the MATLABs, and MATLAB is very familiar with spreadsheet according to the materials. So I am expecting to applying those data sets in the MATLAB. Thank you for your attention. Thank you.
XLS read is the function.
Excel is the function?
XLS read is the function in MATLAB, so you can read from Excel sheets.
Excel sheet. I could take into account Excel sheet.
I actually just opened it in MATLAB too, and it opens it up as a variable.
Yeah.
It's not.
I hope to find something.
I hope so, but these things sometimes are tricky. You just need correlation. You just by pure chance you find some correlation that you don't know is real, right? Because you have lots of time series you correlate a whole bunch of them. Some of them will be correlated, but they actually have no relation. It just happen to be by chance. Because also
by chance.
time series is kind of short.
Like a multicollinearity or something like that.
Yeah. So that's always a risky thing. Because say you have
spatial and
if you do 100 correlation, then 5 of those will be above the 5% significance. It's just by pure chance, right? Just random data. If you do 100 correlation, 5 of those will be 5. So you find those 5, say, I found 5 correlation, but it's actually random noise. So that's always difficult.
But if I could find the more 5%, maybe more 20% or 30%, maybe that must be useful.
No. If it's a real data, usually the correlation is still a lot higher than just the whatever 5% noise level, right? Significance level. But just from pure noise, you can find things above it, so it's very easy for people to say, I found this significant correlation, but it's actually just from analyzing lots of time series, you can always find significant correlation.
According to your paper, you mentioned that the correlation is 0.63. Is it good? Correlation.
It depends degrees of freedom, right? If you have lots of degrees of freedom, that's a good one. But if you only have a few degrees of freedom, that's a poor one, right? When you do correlation, if you have lots of data.
This case, at this stage, when this data has 1,000, using 1,000 data sets. Starting from this is a weekly data set starting from 1978 to 1998. So each year has 51 points. So the 51 points multiply 20 years.
But they're not independent because the ICE has auto correlation. So if you have 1,000 points, but the auto correlation is say a whole year or something.
No, that's a problem.
No, we don't actually know that.
Thank you. So Alexander, will you please, not now, but later on, if I started to work on the comparing with CIS extent with Arctic flow events, maybe I need your suggestion at that time. Alex? He's out.
Yeah, he's seeing it, brother.
Was that, sorry?
No, it's okay. I tried to work on the calculate the relationships between CIS extent and Arctic flow events dataset you provided last year.
Yeah.
And the Arctic flow event data is a daily data set, and the CIS extent data is a weekly data set.
Yeah.
So maybe not today, but near future, I need your suggestion. How can I compare with daily data sets with weekly data sets?
They're just aggregate count.
So not now.
Events per week.
Week. So maybe I have to think of that.
Okay.
Okay, thank you.
So Michael is going to go next.
Okay, yes. Please. Okay.